Hey, good afternoon, Jan.
Hi, Michael.
How are you
How are
doing?
you?
Very good. I think I'm getting the room audio rather than uh, your headset.
See what goes wrong. Yeah, indeed. Um,
I think it should be better like this, no?
Yes, yes, indeed.
Okay. Wait. What is checkpoint? Looking back at your 2005 on Discord. No, dismiss.
There we are.
Um, then I opened Zoom. Okay, ready to go.
Excellent. Yeah, and yeah, the oh, something on the exposure maybe on my camera looking really strange. Mm-hmm.
Yeah, that
Yeah.
gave a little bit. Give. It's a little bit more color,
Yeah.
but it's vintage color.
Yeah.
A little bit brownish, yellow brownish, but it's nice. No, that's too
No.
cold.
There we go. Right, right there. Okay.
That's much better. That's much better.
Okay. I think we got everything straightened out. Yeah.
All right.
Yeah. So yeah, been a couple of weeks since we spoke last.
Yeah, because I was in Belgium for the second time.
Yeah.
Um, but everything, I I was lucky that I reserved a little bit time because I was there to help my son.
Mm-hmm.
But finally, just in time, got everything done. So he's happy. He's happy now.
Excellent.
Um,
Yep.
so
Yeah. Sometimes you need to provide that tech support for the family.
yeah, it was more on hardware than on software there.
Mm-hmm.
But then it made me a lot of things which I didn't looked into for a long time. Like for example, all the PCIe versions, the expansion slots, even all the USB versions.
Mm-hmm.
USB, which you always use, but if you start looking back at all these versions and Thunderbolt, then you say, what a mess. And like HDMI connections,
Mm-hmm.
uh, with all the protections and all the different versions and all the resolutions and
Oh yeah.
uh, yeah. When you use it, it always works,
Mm-hmm.
except when you need to have the maximal performance out of things.
Mm.
Yeah, then it
Right.
becomes critical.
Yeah,
So
and you don't realize, oh, it's this particular cable that was the problem
yeah.
versus a setting on this box or on that screen or whatever.
Mm. Yeah, it was a combination of a lot of things, but everything got settled, got
Mm-hmm.
repaired, got working. So happy son again.
Excellent. Excellent.
I
Well,
saw
yeah.
your I saw last week's recording that you did
Yeah.
about
Yeah.
the
Jinaga Cascade.
Cascade.
Mm-hmm.
Um, I looked back, I think 4 weeks ago, to what you demonstrated then, the code of the core
Mm-hmm.
of Jinaga Cascade. I found it back on GitHub as well, but I have to admit that I don't really,
Mm-hmm.
still not really understand how it works inside. No, I didn't have too much time to look into it, but it's amazing. But for example, where where are the intermediate results stored? So you have a
Yeah.
pipeline. Every time you add something, there is an on added and on removed.
Mm-hmm.
But is everything stored in memory then? The whole.
Yes. Yeah. It's all in memory. Um, so the idea of the core is that it's something that runs inside your browser, and so as and it, I originally created, of course, for a Jinaga result. So as you're
Mm,
getting new facts added or removed, then you put those through the pipeline, and then it updates its internal state in order to understand what that one fact does downstream.
mm,
So yeah, each operation is a login type of operation in the worst case. Sometimes it's just a simple pass through, so it's
Mm.
a constant time operation, and um, and so you kind of flow through the various steps. Each one has its own internal state, and then when you get to the end, it updates a in the case of a React application, it would update React state, and then that's bound to the view.
But it's especially useful if you have a lot of data,
Yes.
because you don't have to recalculate everything. But in that case, imagine you have an enormous collection of data. It's not going to fit into memory.
That's right. Yeah. Yeah.
So,
So
so
this.
storing everything in memory looks like a little bit contradictory with large data sets.
Yeah. Yeah. And so yeah, this is one step along the path that will eventually lead to something that will solve that problem. So yeah, I originally created this while I was working on Launch Kings, and so yeah, in Launch Kings you receive a new fact and you immediately update an array in memory, and then you run all of these processing steps on that array. So so that means that that each processing step is order n log n. It's processing the entire set, and so. And so I created this so that, and you know the upshot of that is during the Launch Kings event backstage, as the evening goes on, updating the running total gets slower and slower. And so and then when I started to add some new features, like for example geolocation, so you know determining who's voting from within the event versus outside the event, that processing added even more to it, and so it really started to bog down. And so this is an improvement over that because we're processing things incrementally as they come in, but it's still all within the browser, and that's not ideal. In order to achieve the results that we want with big data sets, we'll need the processing to happen in infrastructure in the back end, and then the browser will just subscribe to the results, which the output of this pipeline is really very small. It's it's and in the case of Launch Kings, it's just going to be vote totals. So you've got 6 finalists, and they each have a number, so it's a very small set. So if you do all the processing on the server and then you just pull back those 6 numbers in a feed, then things are really fast and really small for the front end, and you can take advantage of persistence on the back end for those intermediate states. So yep. This is originally the idea with the library is okay. Let's take this processing that I'm this pattern that I'm using specifically for this application and generalize it into a library. And then once I've got those patterns for the library, now I understand what a persistent Jinaga aggregator would look like. So, so yeah, there will be a Jinaga aggregator that sits next to Jinaga replicator. And so it subscribes to feeds from the replicator, runs them through pipelines, and keeps the persistent intermediate states in its own database. And then you can subscribe to the aggregator through a different kind of feed. It wouldn't be the same as a Jinaga replicator feed because you're not talking about immutable facts anymore. You're talking about mutable results. So you subscribe to that feed, and then you'll get those results into your application.
And does that also, because in Jinaga we had the problem, it's not really a problem, but certain calculations were not possible within Jinaga. So we had to do them offline in a report generator or whatever,
Mm-hmm.
or a search engine, a special search engine. With this system, would that be solved then?
Yes, it would. Yes. So
Okay.
yeah. That in the book, right at the beginning, we talk about the things that would not be good uses of immutable data structures.
Yeah.
Is it in the? Yeah, the problems with immutability. I mean, it's right here on. Wait, no, that's right at the beginning. Yeah. Okay, I think it's at the end of chapter 2. Yeah. Yeah, that's right. Chapter 2. Okay. So, yeah. Limitations of historical modeling. That's the section.
Mm.
So yeah, we yeah, in here I list no central authority. The problem there is that you don't have one decision maker. So an aggregator doesn't solve that problem because the decision maker needs to have its own state that that it itself can mutate, its own journal. And the aggregator is not a a kind of state that the surface itself can update. It only responds to things, so it doesn't solve that problem. Or the real-time clock problem. No uniqueness constraints. But no aggregation. That's the problem it solves.
Yeah.
Yeah. So the idea there is that in order to understand the total, like maybe your account balance, if you've got a history of transactions, then you need to pull all the transactions in order to calculate the balance. And so, so first of all, if it's just I'm after this number, then you're going to have to do work to get it. But then, if on top of that you are using that number for some other process, like I want, I want to know my top 10 customers.
Mm-hmm.
So I have all their order history. So for all of my customers, I have to add up all of their order history in order to figure out how much they ordered in the past year, and then sort that and get the top 10. So yeah, if you are computing the sum, then you can't index the sum. So yeah, with a persistent aggregate, now you can store that incremental sum while you're computing it, and then you can index it and update your index every time you get new information. So a new order comes in, I update one sum, and then I re-index that one thing, and then I can see, does this one enter the top 10, and who does it kick out? So yeah, that's...
So you still have to be certain that you have all the facts in. That doesn't change, but the moment that that fact, the last fact comes in, you immediately have the end result.
Yeah, and you're right. That still is a problem of I don't know what I don't know. I don't know what information is out there that is not part of this aggregate. And so, the way that that you would use an aggregator would be kind of with that knowledge that that things still might flow into it. Like actually, Launch Kings is a great example. So at one point in the evening, so we've got all 6 finalists that do their presentations. People can vote at any time, and then at some point in the evening, we're up on stage, and the MC says, stop the vote, and so backstage they push a button, and that pushes out to all of the clients a state change. It's like we have closed the voting, and so not all clients are going to get it at the same time, and so they're going to update their user interface at different times. And besides, that's just a user interface change. It just disables some controls. And so for those reasons, it's entirely possible that that you'll get votes that are coming in later. So
Somebody might be offline, so his user interface is not blocked yet.
yeah,
He's still changing or adding his votes offline,
mm-hmm.
and then the blocking comes in, but the result goes out.
Yep.
Yeah.
Yep. And so we've got built into the event itself a duration between we've stopped the vote and now we're tallying the votes, and then we announce the winner. So I mean that's already a natural point in the event to add some drama to, and in fact, when they were doing everything with text messages. There literally was people putting things into spreadsheets backstage during that time period. So yeah, things are better now, but they're still not immediate. You can just push the button and you know what the total is. So so what we do now is you push the button to stop the vote, and then sometime later you push another button to lock in the results. So so you can still see the results changing once things kind of seem to settle out, and it's like, okay, we've given people enough time. Then you push the button, and so at that point, the admin application takes that tally and creates one fact that has those vote totals. So so yeah, new votes could come in after that point, but we've already said these are the totals that we're going with. These are the official totals.
But that has always been like that. I remember when I 30 years ago or 40 years ago, when there was no internet, if you wanted to participate to a competition or a lottery or whatever, you had to send in a letter,
Mm-hmm.
and then the postal stamp, that date was counted as valid or not valid. So it had to arrive in the post before a certain date, and otherwise. So it's in fact the same thing.
Yeah.
You don't go online, you vote, but you don't go online before the date. Your message will arrive too late, and it's not valid.
Yep. Yeah.
There's nothing you can do about it.
Mm-hmm. Yeah, and that's kind of going back to the whole premise of the book. That's one of the things that I love about historical modeling is that it captures the reality of the world anyway.
Mm-hmm.
Yeah, that never was possible to stop the vote at a particular time and know what the results are. So yeah, let's make it obvious by the simple fact that you can't express that in the language.
Mm-hmm.
So yeah, the aggregator will basically do that tallying on an infrastructure component. So it's not happening in the admin
application
browser. Yeah. And so yeah, there is one problem that occurs. So I've during each of the code lives I've been or code launch events, I've been using the admin application on my machine while it's also being used backstage, and so I can see what's going on backstage. And so I have observed that if I refresh the browser tab, because of course I'm testing everything out, so I'm going to refresh and I'm going to try all the things. So I refresh the browser tab during the evening, and then I see all the votes come in, and I see zoop, 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 and they come in little chunks, and it updates things, and it updates things, and it updates things. So yeah, because it's all happening in the browser, it loads a chunk, and then it does the in-memory calculations, because JavaScript in the browser is single-threaded, and it updates the user interface, and then it says, okay, now I can go back and get the next chunk, updates the UI, and so I can see that happening, and yeah, it takes several seconds for it to get caught back up if you happen to refresh in the middle of the event. So having this,
yes, then it has to restart from scratch.
yeah. Yep.
Okay, it will receive all the facts again from the replicator.
Right.
Yeah.
Yep. Mm-hmm. And so the going from the set-based operations to a cascade set of operations that will speed that up. So it'll still it'll still have to start from the beginning, but you should see it, you know, get to the final result much more quickly, because it'll load a chunk, it'll run that through the through the cascade, rather than update the array, run the aggregate, update the user interface, and then the next one in, update the array, run the aggregate. So that part would be compressed, but it would still be loading multiple chunks. So going from there to having a Jinaga aggregator, then you refresh the page. It just asks the aggregator what's the current state, and it'll immediately come back with here's the voting tally.
Because the aggregator has the intermediate data still available, even if you refresh the browser. Yeah.
Yes. Yep.
Okay.
And since the aggregator is going to be persistent, it's going to have its own database. Even if you restart the aggregator, it's not going to start from the beginning. It'll just pick up where it left off.
Okay. That's great. But then the question, how can we, because I still really don't understand how that is done in the software. And so how this can be applied to the state in Nawiis.
Yeah.
First of all, so I was thinking that every field, every step you do is in fact a state.
Mm-hmm.
But if we do that, it becomes very complicated because the number of states changes enormously. Wait, let me, where did I have, let's see whether I had that validation report very close to me. Yeah. Okay, it opens. Was it here? Validation. Validation, for example. Oh, these were the release notes. No, that was just that. Too many documents. Okay, let's make that a little bit smaller. Like, yeah, that's perhaps like that. Then share that. Yeah, this one. You should see now. Let's, for example, this one. You is it visible?
Yes.
Perhaps I should make it a little bit.
Yeah, if you make it well, yeah, if you make it a little wider, we should be able to zoom in better. Right.
Like this.
There we go.
Yeah. So could every field, every step, every text box could be a state. For example, in this test, at this moment, we could here put click on this button, which says accept this test as finished.
Mm-hmm.
Because the user still has the possibility to continue, but here we are almost at 60,000 kilogram, 59,280.
Mm-hmm.
So the inspector is allowed to accept that as terminated. But he could also go on. So the number of states changes according to what he does. It also depends on the number of inspection steps that he added here. It might be less, it might be more. So that changes all the time.
Mm-hmm.
What I could do is say, because if you do this inspection, you go you go down until here,
Mm-hmm.
and then you go up again. So you put like
Okay.
40 kilo on. This is for a bridge for cars and for trucks. So you put first 40 kilo, and then you see, yeah, this one you put 40 kilo, and you check with the weight scale, what does it measure? The weight scale says 40 kilo. You
Mm-hmm.
enter it, it says error is 0. Then you put 400 kilo, the weight scale says 400 kilo, and so on.
Right. Yeah.
For example, here you put 30,000 kilo, the weight scale, the indicator gives 30,020.
Mm-hmm.
So the error, the real error of the measurement cell is 14 kilo. It's not the 20 because you have a limit where it balances.
Mm-hmm.
And once you are here, then you do in the opposite direction. So you have 30,000 kilo on your weight scale, and you remove.
Mm.
You remove 5,000, you are 25,000,
Yeah.
20,000 until 40 kilo. And then you start again with, in this case, that's what they call a ballast. A ballast is
Mm-hmm.
is like, so you had certified weights up to 30,000 kilo. Now you have removed everything. And then you take, for example, a truck with sand,
Mm-hmm.
and that truck, it goes onto the weight bridge.
Okay. And now you're
You,
measuring the difference between the truck and.
you measure the truck, but your weight scale has
Yeah.
already been measured with certified weights up to 30,000 kilo.
Mm-hmm.
So now I put on that truck, and it reads that's 29,260 kilo. And so I will use that truck now as a certified weight
Mm-hmm.
to continue. So I add again 5,000, 10,000, and so on to
Yeah.
go up to 60,000. But then I go higher, and here I go down again.
Mm-hmm.
And so when I'm at 59,000, I can say I'm still not at 60,000, so I continue and I go down again.
Mm-hmm.
But so instead of having every field being a state, I could say my state is I'm going up to the first ballast. Next state, going down. Next state, going up after the first ballast. Going down after the first ballast. And then within that state, I could still have substates, but these substates, yeah, they are variable. I'm not sure whether it's clear what I.
Yeah. I got it up to that point, and then the substates, is that related to the business logic we saw in the case statement?
The substate is for example here, the way a single line works. Yeah. So you have a weight. You go and check what is the the system tells you, for example, put 10,000 kilo on it.
Mm-hmm.
Then you fill out what you read from the indicator.
Okay. So it's
Then you have
those
yeah.
Steps for one measurement.
Yeah. Then, for example, you have to add this delta L. That is small weights that you have to add
Mm-hmm.
until the indicator which is by 20 kilo. So it will give you
Mm-hmm.
10,000 or 10,020 or 10,040. So now he reads 10,000. And then you're going to add small weights by 2 kilo each time.
Until you see the
And at a certain
number change.
at a certain time, at a certain moment, it will go to 10,020.
Okay. And so that's how you know the error was 14 instead of the full 20.
Yeah.
Mm-hmm.
Because you really have the point where he switches to the next level.
Yeah.
And that allows you to calculate the real error.
Yeah.
But so all these steps could be substates, and also in the even in the user interface. So one line could be a view model, could be a view.
Yeah. So does the user interact with the application at every 2 kilo weight, or do they wait until they've got the 20 kilo tick before they come back to the application?
They just add 2 kilo, 4 kilo. They see, and then they see that it jumps, and then the user will enter this number, for example, 18 here.
Yeah. Okay. So yeah, it makes sense to me that that the user would or that the substates would not be helpful because the user's not interacting with the app during those those steps. But yeah, at the point that the user interacts, then that could be a substate. It just wouldn't be as granular as that. Does that does that make sense?
Wait, perhaps let me show you the application again. And then I have to start that virtual machine again. Where is he? Oh wait, perhaps. Oh, the installation on my machine here is not up to date. Yeah, let's get the keys because when I travel, I always have to bring these keys with me. So like that, then open this window. And now I don't see you anymore. Yeah, I see you again.
Okay.
Up. But that was a very big. Last time, how did I do to get it smaller? Because this one is not resizing. Never mind, we will just be able to show a small side of that. Then activate that key in that virtual machine. It's a lot of different steps here, and then go to the working folder, go to Nawiis, find the code. Where is it here? It's already open. Okay, I clicked twice apparently. And then let it run. Okay. So how can I share this one? Right. Let me go directly to such an inspection, because otherwise it's okay. How can I share this now? That's way too big. Let's make that a little bit smaller.
All right, there we go.
That's better.
Yes.
So, for example, that was the test that we were seeing just now. So that's the weight scale up to 60,000 kilo. And I told the system that I only have for 30,000 kilo certified weights with me. So the system tells me you have to put 40 kilo, you have to put 400 kilo, 10,000 kilo, and 30,000 kilo. So fine, my cursor is here. I press tab or enter. It goes to there. I can still change it if I say I don't want to put 400, but I want to put. Oh no, I'm not allowed to change this one. I go there, I go there, I go there. Then I go to the next step. And here it says, okay, you have 40 kilo. What do you measure? Yeah. You put 40 kilo. I measure, for example, it gives me 60 kilo on the indicator.
Yeah, instant fail.
Yeah. And then to go to 80 kilo, I put 2 kilo, 4 kilo, 6 kilo. For example, I have to add 8 kilo. Then you say, okay, so your real error is 22 kilo. Fail. But what I could also do, with Shift Tab, I can go back. I could say, look, I want some more resolution in my testing. Yeah, 400 to 10,000, that's not really. I want to add 2,000 kilo. I want to add 5,000 kilo, and I want to add 20,000 kilo.
Yeah.
I can add more, but I don't do that. I do tab.
And then it sorts. Interesting. Okay.
Sorts. Yeah, but that means that my decisions.
Yeah.
Are going to influence the whole next the whole workflow.
Right. Okay. Yeah. Yeah. So I think we've got two different tiers of facts. There are the measurements. So you've come here to take these measurements. Those are the facts that you're ultimately after. But then there's this intermediate tier, which is how you've set up the experiment. So the different weights that you've added. That's another.
Because
layer.
when I try to analyze the whole problem, the input is actually the customer data. Because the final result is a report. Yeah. I will show you later, but so a report. And what do I need there? The customer data. Who's the customer? Where is that weight scale, and so on? Is all the data of the weight scale? What is the minimum? What is the maximum? How many levels do we have, and so on? The serial number. Then we have inspection parameters. And inspection parameters, there is the measurement results. The results of the inspection, but also the inspector decisions. The decisions taken by the inspector. For example, you can have different type of inspections with different tolerances. So that's an inspection. A certain inspection code tells you you have to take this tolerance. You have to do this tests. Also, an inspector can decide on the whether he does certain tests, additional tests, whether he want to do that test before the other one, whether he want to add additional test points. So that are all the inspector decisions.
Okay, yeah.
So that means we have customer, we have weight scale data, and we have the inspection parameters. And all that together must, if we have that as input, then we need to have a certain output.
Right.
So the testing will be that input data set, the result, and that there is a one-to-one. It cannot be different.
Okay.
So the states and the workflow is influenced by the input data.
Right. Okay. Yeah. Yeah. That's making more sense. Can you, at this point, change the points that the inspector has added? So, like the inspector added 2,000.
Yeah.
Is it possible to change that to 2,500, for example?
No, I cannot go in here. If I want to change that, I have to go back with Shift Tab. Now I can change it here.
Mm-hmm.
I can make 2,500. I can even make, for example, here, let's say 7,000.
Yeah.
I go back.
And then it'll resort
Now
it.
you have the 7,000 before the 5,000.
Yeah.
It'll sort it.
Okay.
Yeah.
But you're not able to change one that is an official, you must have this measurement, right? So
The official ones, I think I could not change. No.
yeah.
No.
Okay.
You are not allowed to change this one. Yeah.
Okay. Yeah. So yeah, this represents a scenario that I hadn't solved for yet in Cascade. So you've got some data that's coming in from business logic, like given the weights that you have, these are the points that you need to measure, and then these facts that represent the decisions that the inspector has created. So these are the inspection points that we've added. So we have to bring those two together, and then just do a sort step. So yeah, there's not much for Cascade to do in this case. It's just sort them. Yeah, if you were to write that yourself in a view model, then what you would do is you'd have the Jinaga specification project out a set of numbers for the additional inspection points, because those would be represented by facts. So you subscribe to that set of facts, you get those numbers, and then you would have another list of numbers that you've just calculated from one of the inputs, which would also be stored as a fact, but a different set of facts that then you do some calculations and you say, okay, this set of numbers. And then, so now in your view model, you've got those two lists of numbers. One of them is hooked up to the specification, so as new facts come in, that one updates. And then you would have some code that just merges those two lists together and sorts them. And then there's also the idea that as you're editing, you're not showing the sorted list, or at least you're showing what was previously sorted, but while you're in that mode, the user can edit certain elements of that list.
Well, there is nothing that says that we cannot sort immediately. That's not a problem.
Okay.
I just did it in this way because it was easier.
Yeah. Well, I think it's easier not just for you, but also for the user, because things aren't changing until they're ready for them to change. If they edit a number and then tab out and now numbers move, then it's not immediately obvious without them just thinking through sorting numbers in their head, which numbers went where.
Yeah, that's true.
But I think I certainly do want to support this kind of user interface, whether you decide to change it or not. But yeah, so that means there needs to be merged from two different sources, which is not currently part of the library that that Cascade, the core Cascade library. That is something that I can imagine how to implement that. So it's not a showstopper. But yeah, you can kind of think through what you would have to write inside of your view model. And basically, what I want to do is turn that all of that imperative code, turn that Turing machine into a declarative pipeline. So So yeah, you're just saying this specification gives me this source of information, and that business logic gives me another source of information, and then this step is to join those two, or really to concatenate those two, and then to sort. So it would be 2 steps.
Yeah, and then the logic, the state machine behind. So somewhere like here, you have to say, okay, I tap, I don't enter anything, no new number. So he says, okay, we go to this column.
Yeah.
And we start the inspection for the first line. So now I enter, for example, I see 40 kilo on the indicator. I have to add 2 times 2 kilo to make it switch to 60. He says, okay, my error is 6 here, which is too big. He's only allowed to have 5 here. Now he says put 400 kilo. This one, I put it in two different columns, because once you use the ballast, then you have in one column the previous, the ballast, and the total.
Yeah, that makes sense.
So here you said, for example, I measured 420. I have to add, let's say, 18. And now he goes to the fourth test, because that test has to be done around 420.
Oh, okay.
Yeah.
Right. So this is that state machine. Yeah.
Yeah. So he switches. So here, for example, the fourth test is the mobility. So you put 420. Was it already? Charge enlevé. So they have to take something off, let's say 10, before it goes to 400. Then you have to add 2 kilo. You have to add another 28 kilo. And then you have to say what he...
Yeah.
And he said, okay, this is good. And then he returns to here, to 5,000 kilo.
Okay.
But so all that logic, that is in that big state machine, in the case structure.
Right.
And I was thinking, so if already every line here, I could represent it in a function. So get it out of that state machine. I use it as a function. So it becomes, it has a name.
Yeah.
Yeah. It makes the whole state machine, the overall state machine, smaller. It says, for example, inspection line with these inputs, and the results will come out. But so I have a description. It's easier to understand.
Yes. And so easier to test. You can test each line in isolation, and it clearly documents what is a dependent variable, what's an independent variable. So these are the things that can change, and then we calculate those dependent variables from them, and then now you can decide how are those independent variables stored. So where are the facts that give you those independent variables? And so we had talked about one tier of facts, which is the new measurement points that the inspector has added. Another tier would be the measurements themselves that you're typing in right here in this column. And it seems like there's a third level, a third tier of facts that keeps track of your progress. Well, you don't actually need that third tier, because you're just looking for the presence or absence of certain facts. So, given a history, I can look at that history and say, I've measured this one, I've measured this one, I haven't measured that one, so that's where we are, and then update the user interface accordingly. So yeah, I think we still are just at those 2 tiers.
Okay. Because in the way I implemented it now, so to step forwards, it's a state machine.
Mm-hmm.
But then if I do shift up, I go backwards. And I don't want to implement the inverse state machine. So what I did was every time I go to the next, I keep an array of the cells that I run through.
Yeah.
And so if I go back, I can just go back in that array.
Right.
That was easier to implement.
Yeah, so the way that you would solve that problem in this other pattern, so this other pattern, again, is that you've got facts that represent your independent variables and then functions that compute through your dependent variables. And you can tell where you are based on the presence and absence of facts. So the way you would go backwards in that pattern is that you would have a successor to a fact that says, undo this measurement. So a delete pattern on each of the individual measurements. And so that would be part of your specification. So where not exists that delete. And then once you add that fact, it's going to update the specification, and it's going to look like you were 1 step earlier. So you're going to get back the same projection as you did before. And so when it runs through those deterministic functions, you're going to get back the same dependent variables as you did before. And bind all that to the user interface. The user interface goes back to the state that it was before. So yeah, even the navigation. Usually we think about tabbing through something as just setting focus to one control versus another. But even that is a dependent variable. Which cell are you in is based on all of this information. So it's one way.
Yeah. So actually, the whole thing could be a specification.
Yeah, a Jinaga specification is not powerful enough to represent the whole thing, but yeah, Jinaga specification plus a Cascade pipeline gives you the pipeline gives you that additional aggregation that you would do over the projection results. So that would be powerful enough if pipelines supported multiple input sources. So yeah, add a join and a concatenate operator to the pipeline, and those would be 2 ways to bring in other sources. And yeah, then I think you can do all the logic inside of a pipeline.
Because initially, the way I was looking at the problem was, I need Jinaga to synchronize the customers, synchronize the weight scales, and to synchronize the results. But I've never thought about translating the state machine into pipelines. It's a coincidence that you were just working on that when I came with this problem. So I thought the results, we just store them in a big collection, and we send them as a whole in a Jinaga fact.
Right. Yeah. So you're just doing a whole bunch of things in memory, and yeah, if that laptop crashes, so it was all in memory, then you would have to start the experiments over again, or.
The way I do it now, after every test. So this is, for example, test 1. After every test, I save it.
Okay. Yeah.
They cannot restart an inspection from saved data, but all that is saved, they can print it out. So they have all the input, and so they can.
And then they go through and enter that as if they were
Yeah.
doing it again. And that sets up that that undo buffer because they're entering
Well,
it.
yeah.
Yeah.
In theory, according to the legislation, they should do it again.
Oh, okay.
Yeah. Because you start and you end, and yeah, it has to be a normal, standard workflow to do this inspection.
Okay. All right.
Then
Yeah.
I was also looking at 2 weeks ago. We looked into test possibilities.
Mm-hmm.
I think that in the end, the best thing that I would be to do. I have all these that the validation reports.
Mm-hmm.
That I built some tests around these validation reports. Yeah, I have in the validation reports the input data and the output data, and also the decisions that the inspector took. So
Yeah.
and that really I built the tests around that, and that we don't try to make some automatic tests in VB6, because I don't really see how. Because we have to start from a user interface,
Right. Right.
something that is not really testable.
Mm-hmm.
And okay, to enter that data one time in a test framework is not that difficult.
Right.
But then
Okay.
it's a clean number of tests.
Okay. Yeah. So that yeah, that does. We lose the ability to know for certain that the new system works exactly the same way as the old system, but what we gain is the ability to express what the new system should do from original sources. So if there was a bug in the old system, and we wrote the tests only to test the new system, we wouldn't know that there was a bug in the old system. But yeah, what we were going for there is to make sure there wasn't a bug in our tests. But yeah, if you write the tests straight from the from the legal requirements, then yeah, you would want to have enough examples to satisfy yourself that yes, these tests are really measuring what it says I need to do in this document. And you could manually go through those scenarios in the existing system and just capture once that yes, the old system worked in this way. Yeah, that might be sufficient.
I have these tests that I use as validation.
Yeah.
What I could also
so you've already run those through the old system many times. Yeah.
Yeah. What I could also do is production data from my customers, because they are doing thousands of tests with it.
Yeah.
Use that data and the output to test the new system.
Yeah. Okay. Okay. All right. So then we just need a reliable way of getting from the report to a test.
Yeah.
And that could be an AI thing. It could be it could be a manual thing, but it sounds like there's a lot of data and you don't want it to be manual, and you can make a mistake that way. But that could also be a deterministic automation. Have AI help you rate the deterministic automation, but then when you're running it, you're not using AI to do the OCR on the PDFs, but instead you're just inspecting the PDF and finding finding the number inside of it.
But and even not from the PDF, from the database with the results.
Oh, okay, right, yeah,
Yeah,
even better.
I can ask my customers to have data. They will have to remove for legal requirements their customer names, but
yeah.
Or I could also do it from the reports, but for example, this this is a report. So here you see the results from test 1, test 2, test 3, test 4, test 5. It's very dense. But why is it so dense? Because at the time in 2000, when I started this, the customers, the users, they had a small carry case with the computer in, with a small inkjet printer, because there was no internet. So they had to print out the report at that time. Now the cartridges were quite expensive with the ink.
Yeah.
So they could not print 20 pages, and they wanted to have the report not to lose anything, just on one page.
Yeah.
So that's where this comes from. But then afterwards, I made for example, here, this is an extended report.
Yeah, I'm still seeing the application. I'm not seeing the reports.
Oh, okay. Wait. Yeah. I will show you that one. Where was it? This one, I think. Yeah. So.
Okay. Yeah.
So
the one page.
So this is the main report. So here you have test 1, test 2, test 3, test 4, test 5, and so on. But so then there is an extended report. That is this one. This is the data about, for example, customer. Here the inspector, the customer, and the weight scale. And here you have the data from test 1. Second page, test 2, test 3A, 3B. And that's the way I'm going to do it now, because now they don't print anymore. It's a PDF that is emailed to the customer. So, and also in the test itself, before it was a grid, I could have, I think, 19 lines maximal, 19 weights. Now I would like to make it unlimited.
Right, yeah.
That's also going to be easier on different user interfaces, tablet, PC, and even telephone. I think it's going to be better. But so the reports are going to be much cleaner. If it's longer, it takes more place. If it's shorter, it takes less space. But so I could read it with OCR from the reports, but from the database is a lot easier.
Right, yeah. Yeah, if you've got that, that's...
Yeah. And so there, as you said, I could use artificial intelligence to convert, to extract the data.
Right.
And put it into tests.
Yeah.
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 But so the main problem is going to be to make the state machine in a clean way.
Okay.
What do you think? Is it best if I initially try to make it with functions, so a global state machine with case selects, and then as many as possible functions to have something that is understandable?
Yeah, there is some advantage to that, in that you would be starting from existing code and then refactoring. Of course, you're refactoring without tests, so it's not true refactoring. But at the very least, you're giving the assuming that you're using an LLM to do this refactoring, you're giving it some ground state and saying, okay, this is what it should do, and so it'll generate code that to the best of its ability does the same thing. So that's that would approach it from one direction. Another direction would be to just be completely test driven, and to take one simple example from the database and then create a test that describes exactly what you want the view model to look like, what the interface to that view model should be. So yeah, given these facts, then I expect the view model to be this, and then you can you can iterate through the layers of that view model. So yeah, one of the pieces of the view model will be a projection from those facts. So you could write a test that's just, given these facts, this is the projection that the view model sees, and then maybe another test would be the aggregation. So given that's the data in the projection, and that's the data that comes from from this other projection or this other business logic, then this is what the aggregate should be. And then eventually you'll get back to that first test that you wrote. And now that you're putting those pieces together, the view model acts in this way, and it produces these results. So, yeah, I see advantages in both approaches, starting with existing code and refactoring versus starting with tests and doing the test-driven. My preference, given that I wouldn't have tests to do the refactoring, would be to do the test-driven. And then you know that you're done when you've gotten through all of the test cases. And so you're making the assumption that there's not any logic that's in that case statement that isn't used in one of these test cases, which is probably a pretty good assumption.
Certainly, if I would use production data.
If there's a line of code that hasn't been touched by all that production data, then what's the scenario? What's the reason for that line of code?
Okay. Good. And then try to make a framework that is as clear as possible and extend it step by step.
Yeah.
Because it's the most important thing is having a solid base, and afterwards on that base I can add all the tests and make it grow.
Yeah.
But if I start with the spaghetti, I'm lost.
Yeah, I think so. So I think that's the way to go. And so now, next Thursday and the Thursday after are Christmas and New Year's Day.
Okay, wait,
so,
let me see. Yeah, it's 25th and the 1st.
Yeah, so how about you get started on that? I want to rewatch this video and then see if I can come up with what are those facts in those different tiers, and so we can check in with each other via email, see where we are, and if it looks like we can put together a show and tell to talk about where we are in between, then we can just go ahead and do a stream at whatever time. So
that would be great.
Rather than our regular Thursday morning or afternoon.
Okay, I'm gonna work on that, and then if you meanwhile you have questions, let me know, and I will keep you up to date about progress I make.
Sounds good.
Okay. All right, Michael, thank you very much.
Yeah, thanks, John. This is a really fun example.
Yeah. See you one of these days then.
Yes. We'll figure something out.
All the other people see you on the 8th of January then.
Yes.
Okay.
All right.
Bye-bye.
Bye.
Thank you very much.